Hi my friends, and welcome back to our Semantic Manager lessons. Let's open our Semantic Manager. And my friends, again, if you don't have Semantic Manager or WinCC or Yokogawa, you can visit the tasco.az and request for the virtual machine, and we provide you with this machine, tasco.az. And here I switch to my own project. Now let's return to our lesson 1. Sorry, let's firstly close all project because another project is still available. That's why let's switch now. Press OK button. And my friends, in today's lesson we will talk about the analog signals. Firstly, let's open our hardware config and open our analog modules and open object properties. And here we have the analog signals where you can configure it to measure the voltage or the measure of current, and here you change it from 4 to 20 milliamps. Let's cancel it now. And now my friends, I want to show you how you measure it if our simulator is how we visual inspect the signal, and let's do it like this now. Edit symbols, and we have PIW 700. Let's write it here before we start our simulator. PIF 752. And let's close this one and also close this one, and let's firstly try to look at it from the variable tables. What one? Okay, and here let's add our, I think we cannot see it, but I will try with you, and let's do decimal. Now let's start our simulator. If it not start now and we cannot do it, in the future we will write program, and of course we can change our values. And now let's download our program to simulator. Enable to module. Sorry. Cancel. Okay. Firstly, let's check our network, disable it, and try again. Unable to reach the goal via the online interface. Yes, my friends, I can manage I can troubleshoot the problem. Problem is that we are not at any TCP/IP or Profinet or Profibus connection here. That's why we will choose the MPI instead of TCP/IP, stop it and run it again, and then we can download the program. Yes, let's look our. Okay, now let's open our lot table and look if we have to manage and change the value of our analog module PIV. Now let's change it from here, right, 30, and yes, we can change it. So my friends, let's begin our lessons about the analog signals, and I want to explain you some measures and how we measure the analog signals. Let's firstly open our OB1, and I want to show you how we manage and calculate the analog signal. Here we choose the FPD, and let's add here our move instruction, and here we have our PIV 752. Press enter, and output we must use the word data type, and let's use the MW44 for store our data. And here let's save our program, and then let's download it again to our PLC. Let's choose the MPI P and download it. Yes. Okay. Yes. Yes. And now let's simulate it here, and now my friends, you will see that we must change it to represent in decimal value, and here again you can change the value. You can add your own value, for example 40, and press enter button. Now we have the 40 value here. I change it to decimal, and now my friends, I want to explain you something about our modules bit capacity. For example, when you faced with a model like this, E5 or AO2, and it's multiplied by 12 bit, it means that we have the model with a bit capacity like the 00001xxx. The last 3x, it means that we measure our value using only the 5 bits, and it's mean when we use the model with the 14 bits, and then our measure become more accurate. And we come to result that the greater the model with a greater bit it's give us the more accurate result than in other models. And now, my friends, let's quickly move to transformation formula. I mean, how we get the result from our analog signals. Let's open Paint now, and we have the graphics like this. Sorry, some mistake, like this. And here we have let's no, sorry, before I want to change the color of our line. Sorry, let's do it like this and like this. And imagine, my friends, you have the voltage line here, V, and our measurement value is here. For the Siemens PLC and for Schneider's, as I know, and for the Mitsubishi, we have the, I think it's a standard for all PLC, but I talk about the value which I faced in my work is the maximum value that we can measure is the 27 and 648, and the maximum value is the when we go out from our range is the 32 and 767. And in our voltage we have when we measure this signal, this value, we get the our voltage is about 10 volts. And if we measure from this this value, we get the voltage about 11.85. And I think from the schools and from university, you know that this chart has a formula like if we take this value, our V, our N, this is our N, let's write it here, our N. This chart have the formulas like this. V is equal K multiplied by N. And for example, my friends, if we want to find the voltage or value on this point, our formulas will be equal to for example, if we take this value like U1 is equal to UH divided by 27,648 and multiply by the N1. N1 is our value from here. Let me connect it this one, and here is our N1 and here is our U1. So my friends, that's all for today. In the next lesson we will continue explore the formulas by this graph and another graph when we use some span. So I wish you all the goods. I wish you good health, and I wish you good like. Subscribe to our channel and hit the like button if you enjoyed the video.